Okay, so if any of your friend is absent, please call and ask to join the grooming as soon as possible. Okay, so let us go for the grooming. Just yeah, what we have done in the yesterday session. Everybody has done with the assignment. Yes or no? Yes, everyone has uploaded. Okay, so let us go for the next one. Okay, so I guess we have we have started with the sorting algorithms. Yes, and we have seen bubble shot and which one? Insertion or selection? Which one we have seen in the last session? Yes, selection shot. Okay, I will give you 2 minutes of time. Quickly revise bubble and selection shot. Quickly go through your sorting algorithms and read one more time bubble and selection. Then we will go with the insertion shot and heap shot. Yes, so let us go with the next remaining sorting algorithms. Okay, just close this one, opening the word. So we'll write it here. Technical grooming. Okay, so let us start with the insertion shot. So what is insertion shot? Again, it is a sorting algorithm. In searching algorithms. Okay, is my screen visible to everyone? Yes. Okay. So let us say what is the insertion sort. So suppose there is one array which we need to sort. Let's say 752 1 4 7. Okay. So what insertion sort will do? First, you have to compare this two elements. You have to compare. You have to compare what? Let's say the index is 0, 1, 2, 3, 4, 5. Okay, so what you have to compare? You have to compare a of 0 is greater than a of 1. Then slowly we'll increase this 0 to 1, 1 to 2, like that. Okay, so if it is true, it can be true, it can be false. If it is true, what we will do? We will swap the values. So you can see 7 is greater than 5. Yes, true. True means swap the values. So what will be your next this one? That will be 5, 7, 2, 4, 7, 1. Okay, this is 7. Two sevens are there, not a problem. 7 and 1. Now this 2 is shorted. Okay, now this 2 is shorted. What you will do? You will take this third one and you will compare with 7. You will say, is 2 is less than 7. If you find 2 is less than 7, you have to swap the value of this 7 and 2. So now it will become 5, 2, 7, 4, 7, 1. Still the place, okay, we are only working with this 3 element. Still the place is not fixed. Again you have to compare 2 with 5. First you will compare 2 with 7. If it is greater, swap. If not, keep it like this. Then you have to compare with the 5. So you have to compare this 5 also. So again, it is less than. So what will happen? This will get swiped. And the final you will get is 257,471. Now these three are shorted. Again, what we will do? We will compare this one with 7 first, then we will compare this 4 with 5, then we will compare with 2. If we find it is less than, this number is less than the compared number, means we will swap. So first you will compare 4 by 7. What do you think? Is 4 is less than 7? Yes. Then this 7 and 4 will get interchanged. So what will happen? It will become 254,771. Okay. Again, you compare this 4 with 5. Is 4 is less than 5? Yes. Then it will become 245,771. You guys can again compare this 4 with 2. Since it is greater than 2, so we will not swap the numbers. Okay. After that, you will take 7, next number, and 7 you will compare is less than equal mean, it will not get changed. So now the final will be 245,771. Now last value will be there. This is shorted. Last value will be 1. You guys can see this is what the biggest comparison. You have to compare this 1 with everything. If it is small, if this 1 is less than, then you have to swap the values. You guys first compare it with what? 7. It is less than, yes, then it will become 1 and 7. Again you compare this one with 7. Again it is less, it will become 1, 7, 7. Again you will compare, it will become 5, 1577, and you can see this 1 will go at the there, and this all remaining will shift it to the right side. So the final will be 1, 2, 4, 5, 7, 7, and you guys can see it is shorted. Okay, by looking at your face I'll understand. You will not understand anything, so we will repeat it one more time. So now let us go for that. Okay, so I'll take one, let's say number 2519. Okay, I'll try to short this 4 by which one? Insertion short. First, I will compare this two numbers. Listen it very carefully. Concentration. 2 to 5. Is 2 is less than 5? I write it here. Is 2 is less than 5? Answer is true. If it is true, this 2 is fixed. Now you will compare with this 1. What you will do? You will compare first 1 by 5. If 1 is less than 5, you will swap it. Yes, 1 is less than 5, you will swap it. Now it will become 2159. Okay, still you have to compare 1 with the 2. So now you will compare 1 with the 2. Is 1 is less than 2? Answer is yes. Yes means swap. Then it will become 1, 2, 5. These three are shorted. Now in the next pass, what we will do, we will compare this 9 with 5, with 2 and with 1. So you can see is 5 is okay, is 9 is less than 5? Answer is false, no swap. 9 is less than 2? Answer is false, no swap. 9 is less than 1? Answer is false, no swap. And you guys can see 1259 is shorted. Are you guys getting? This is what called as insertion short. Understood? Yes or no? Reply anything. Okay, so let us write some point for the insertion short. So what is insertion short? Okay, it is a shorting algorithm. Okay, let us write the algorithm for that. Okay, so what is the first step? First compare the two values. First compare the two values. If the value is less, if the value is less, which means if A is less than B, then it is okay. If it is false, swap the value. If it is false, interchange the value. Okay, then take the third element and start comparing with the other element from left hand side. Okay, you will start comparing the element from the left hand side. Yes, if the element, okay, if the element is less than, okay, if the element is, let us say, greater than, then swap the values. Understood? And what is next? Repeat the step for the n element. Okay, just read it 1 minute. Everybody read it, read it. Yes, okay, I'll copy and paste this two screenshots. 1 minute. Okay, now let us go for heap sort. So remember binary tree, heap sort we required binary tree. So heap sort is a sorting algorithm which will work on heap, which will work on heap. Now what is heap data structure? So heap is nothing but binary tree. Now what is binary tree? Binary tree is a tree that consists of parent and child node. Okay, let me write it first. So heap is of two types. The first one is called as, okay, the first one is called as min heap, and the second one is called as max heap. What is min heap and max heap? Let us try to understand. Okay. Yes, you guys know binary tree. Okay, so let us go for min heap. So min heap means data of child, data of child will be less than the data of, sorry, the parent data will be less than the child data, which means if this is node, okay, if this is a tree, if this is a tree, then parent data will be less, child data will be more. Understood? What is the meaning of that is, so if you are inserting any value, so let's say you insert 4 in the parent, then child data should be more. It will be 6, it will be 7, it will be 10, anything. This is what called as min heap. If you are making this again one more min heap, then you have to make sure this is the parent, and the data which you will insert here should be more than that. It can be 7, it can be 50, but it should be more than this one. This is called as min heap. Same like that, there is one more called as max heap also. There is one more called as max heap also. And in the max heap, what you guys have to do is, it is the reverse of it. If it is a binary tree, then for the max heap, value of parent, this is what? This is the parent. Value of the parent should be more than the child, which means child value will be less. Let's say 9 or 7. If you are making this as a parent, its child value should be less than 9, let's say 6 or 3. This is called as maxi. Are you guys getting everybody? Okay. So let us go for this one. So first what we need to do is, in order to do heap shot, we have to first make either max tree or, sorry, either min heap or maxi. Okay, so suppose, okay, let me first take the screenshot and paste it. Just give me a minute. Okay. So in order to do heap shot, we have to first make min or maxi. In order to in order to do heap shot, we have to convert the binary tree into max or min heap. Okay. And the operation is called as EP5. Operation to convert binary tree into min or max tree, max heap, is called as EP5 operation. Okay, let us see how we can do that. So what we are doing now, we are converting a binary tree into max or min heap. Okay, so what we will do, you guys can notice properly these things. I'll just increase the width of that. So suppose if you guys have one tree, okay, you guys will be given one array first. Let's say 7, 5, 2, 1, 9. Okay, this is what the array you guys have given. Okay, now what will you do with this array? You will make first tree. How will you make a tree? Very simple. You will do one by one. 7, 5, next, okay, it is 0, 1, 2, 3, 4. 5, then 2, then 1, and then 9. Now what will you do? There is two operations. First you will make this as the first heap and then extract the element or perform the operation. So is it a max heap or a min heap? No. So let us go with the min heap. Okay, we will try to make min heap. You guys can make max heap also. So in the min heap, what we will do, we will compare. We will start comparison from this one. We will see whether this is less than or not. What is min heap? Min heap will be parent will be less than child. Yes or no? Parent will be less than child. So first we will look at this one. We will always start from the last nodes. So this is parent. Parent should be less. So what we will do? I will compare this with 5. If I compare this with 5, and I found the value is less than, then I will interchange. I will make it 5 here, 1 here. Again, I will compare it with 9. And what I will do, if I found less than, I will interchange. So now what my heap look like? It will look like 7, 5, 1, 9, and 2. Okay, still you guys can see this is not performing min heap. It is max heap. So what we'll do, we'll compare because parent should be less. So I'll compare this 5 and 7, and if I found that in the heap it is less, then I will interchange this to 7 to 5. Again I will do one more comparison from my right child end, and if I find again more, then I will again interchange the value 2 to 5. Then you guys can see my heap look like, you guys can see what is the node here, 2, 7, 5, 1 and 9. So I will make it 2, what is that, 7, 5, 1 and 9. Yes, again you guys can see what this satisfy or not. No, it is not satisfied, but because of that change, you guys can see again 7 is there. Look at this carefully. Is it following min heap property? No. Then what will you do? You will again compare. You will again change it this by this. Now it will become 1, it will become 7. What it will become? It will become 2, 1, 5, 7 and 9. Again you can see because of this heapify operation, this is not following the min heap. What you will do? Again you will compare it. So if you find less, means interchange 2 and 1. If there also, you can interchange it. After doing this heapify operation, you guys can see our heap will be like 1, 2, 5, 7 and 9. Now what you will do, this heap is just for representation. Actually it will store in the array. How it will store in the array? This will go for 0 index, this will go for 1 index, this will go for 2 index, this will go for 3 index, this will go for fourth index. So how it will look like, 1, 2, 5, 7 and 9. And you guys can see it is sorted. If you take min heap, it will go in ascending order. If you take max heap, it will go for descending order. Are you guys getting? So again, same example, I'll give you 3 minutes of time. Go to again the same example, and this time try to create max heap. Go for it, everyone. Okay, not a problem. We will repeat it one more time. Okay, Tejaswini. I hope this method you will understand properly. So let's say there is one more, this one, 9, 5, 7, 8, 11. Okay. Let's say this is one array which you need to store it, which you need to first store it in binary tree, then using heap sort you have to sort it. So now this algorithm is called as one by one. Okay, you will take one element and you will do the operation. So what will happen? We will start with the first one. First you will take the first value 9. Okay, you will make a node of it 9. Done, nothing is there. Then you will create one more called as 5. So what is the second step? 9 and 5. Compare it. What we will do, min heap or max heap? We will go with max heap. Okay, so max heap means parent value should be more than child. Okay, so compare it, or you want to go it for min heap. Which one you want, max or min? Tell me quickly. From which heap I'll do that? Max heap. Okay. So this is what, okay, since it is following the property of max heap, I will take my third number. So I will write 9, 5 and 7. And now I will check, okay, whether my number, this child is greater than parent or not. If my child is greater than parent, then I will swap it. So first I will compare this to this one. Is my child is greater than parent? Answer is no. So no swap. Again I will write one more program. Sorry, again I will compare the right child. This is called as left child and this is called as right child. So now I will compare it with my right child. The right child is also less than this one, so no swap. Now it is following the proper maxi. Once it follow, I will go for my next element. What is my next element? That is 8. So I will write 9, 5, 7 and 8. Yes, I have done this one. Now you can observe this part of a tree is not following the maxi, because max should be, you will compare the child with the parent. Now this will comparison will be there will be a comparison. So child is greater than parent, answer is true. If answer is true means swap. 8 is greater than 5, yes, swap. So you will make here 8, here you will make 5. Now both of them are changed. How you are changing? How your tree will look like? It will look like 9, 8, 7 and 5. You guys can check. This is following maxi. This is following maxi. Now I will compare this one. Since you guys can see, it is not following the maxi. So I will start comparing my child with the parent. What is my child? 11. Now what I will do, I will compare this one. Since you guys can see, it is not following the maxi. So I will start comparing my child with parent. First I will compare my left child, then right child. Left child is less than, so not a issue. But right child, you can see it is greater than the parent. So we need to swap it. What we need to swap? This 8 and 11. So here what will come? Here 11 will come and here 8 will come. Now how your tree will look like? So your tree will look like this. That is 9, 11, 7, 5 and 8. This will get settled down, but you guys can notice there is some problem in this tree now. Again you need to compare this tree, and this time you guys can see 11 and 9 will get swapped. So what will be your final tree? That will be 11, 9, 7, 5 and 8. Are you guys getting? Yes or no? It is following the property of max heap properly. Now what will you do? You will extract the first element. This is what done. Now there is one more step called as step 2, extraction. So you will take this first node, whatever the first node is there, you will store it in the array. So this is what the array, and you will store 11 in the array. Now this 11 you have removed from the list. Now what you guys have to do is the last element you have to swipe it with the first element when you are removing, which means now your this tree will look like 8, 9, 7 and 5. Again you need to perform heapify operation. What is heapify operation? Again you will check, is it a mini heap? Sorry, is it a max heap? Yes. Is it a max heap? This one. Answer is no. Okay, why? 8 should be there, 9 should be there. If it is like that, your tree will look like 9, 8, 7, 5. Extract this top 9. Okay, remove it and store it 9 here. Replace it by last element. So now how your this will look like? So this your step 3 will look like 5, 8 and 7. What you will do, again check make max heap or not. If not, interchange the value. What will you do? You will interchange the highest value out of this child, 5 here, 8 here. Now your tree will look like 8, 5, 7. Extract the top, 11, 9, 8. You extract it, replace it with the last child. Now it look like 7 and 5. Extract 7, extract 5. And you guys can see it is arranging in descending order. Are you guys getting? This is how you have to do all these things. Understood? Any doubt? Okay, this will come by doing the things. I'll give you some assignment on that today. Okay, so try to do that. This one is easy or the last method is easy? Which one is easy? It is one by one. One by one you will take it, one by one fix it, extract it, okay, and just interchange it with the last child. Yes, I hope you understood something at least. Yes, okay, so I will write the notes for it. This one is easy. Yes. Okay. So we will write algorithm for heap sort. Okay, which one? One by one I'll write. Okay, that one is easy. One by one. So what you guys have to do is take one element, take one by one element and start creating a maxi. Start creating the max heap. If you go for the max heap, you will get the list in descending order. If you do it for min heap, you will get it into the ascending order. Okay, after that, what you will do? Add one element and try to maintain the heap. Try to maintain the heap. Okay, if max heap is not maintained, perform heapify operation. Heapify means nothing but to make the heap as max. Over here, to make the heap as max heap. Okay, this is what adding step. Then you guys have to start deleting the root node and store it in an array, and replace the root node by the last child, and then again perform ep5 operation. Understood? This is what you have to do it. I will just give you the proper screenshot of this heap shot. Just give me a minute. Okay, so I will give you assignment question here only.